On January 28, 2021, a catastrophic liquid nitrogen release occurred at the Foundation Food Group plant in Gainesville, Georgia. The incident happened during maintenance on a liquid nitrogen immersion freezer, resulting in the release of vaporized nitrogen that displaced oxygen. 6 workers tragically lost their lives to asphyxiation, and 12 others, including a firefighter, were injured. The release also caused extensive damage, with losses exceeding $2 million. This tragedy highlighted critical flaws in safety measures and emergency preparedness at the facility. What happened? On January 28, 2021, maintenance workers began troubleshooting operational issues with the immersion freezer. During this process, a bubbler tube used to measure liquid nitrogen levels became bent, causing an uncontrolled overflow of liquid nitrogen. 8:40 a.m., workers noticed a white cloud in the freezer room but did not perceive an immediate threat. 9:55 a.m., the incident was reported, and employees began evacuating. Attempts to rescue 2 unresponsive workers led to further fatalities and injuries as others entered the oxygen-deficient area without protective equipment. 10:15 a.m., the liquid nitrogen flow was manually shut off, and emergency responders arrived, equipped with breathing apparatus. Rescuers evacuated the building and recovered the deceased and injured workers. What are the root causes? Single point of failure. The freezer's bubbler tube was the sole safety component controlling nitrogen levels. Its damage disabled critical safeguards, leading to the release. Lack of atmospheric monitoring. The facility had no sensors to detect oxygen-deficient conditions or trigger alarms. Inadequate emergency preparedness. Workers were not trained in the hazards of liquid nitrogen or emergency response procedures. Design and regulatory gaps. The freezer design lacked redundancy, and there were no regulations requiring safety systems for cryogenic asphyxiants like liquid nitrogen. Key lessons and mitigations. Enhance equipment design. Include redundant safety measures to prevent single-point failures in critical systems. Install monitoring systems. Use atmospheric sensors and alarms to detect oxygen-deficient conditions. Improve emergency preparedness. Train workers and responders in handling cryogenic hazards and provide proper protective equipment. Strengthen regulations. Advocate for stricter safety standards for facilities handling cryogenic chemicals to prevent similar incidents. Thank you for watching.